Yeah.
Could you solve this problem?
The number I don't really know what the pattern was or like what.
So one hint for this problem.
Sure. Yeah.
Okay, so I told you last session also we worked on this. I told you when we have a smallest or greatest, maximum or minimum, we should do what?
Find the range.
Yes, because we should consider the range, right?
Yeah.
Okay, let's quickly read it. 30 cards from 1 to 100. It takes cards out of the deck one at a time and places the selected cards in a row. With each new card added at the right end of the row, Matthew must arrange that at all times the mean of the numbers on the cards in the row is an integer. Okay. If at some point there is no card remaining in the deck which allows Matthew to continue, he stops. Okay, when Matthew stops, what's the smallest possible number of this? Okay. Now let's consider answer less than or equal, greater than equal. Have you found any number for any of these two sides?
Well, last time we just would try.
We worked on a small example last session to understand problem better, right? So, for example, one obvious thing. Do you agree it is at least one, at most 300? One obvious thing.
Um.
When we have
Yeah.
300 cards, obviously it's at least one because when Matthew selects the first one, the mean is always integer because a1 over 1 is integer, right?
Yeah.
So let's first work a bit on this one. Can we say answer is at least 2 also?
Yeah, because if A1 is odd, then you pick A2 to be.
Exactly, because we have 150 odds, 150 evens, right?
Yeah.
So number of odds is equal to 150 number of evens. So for first card, when we have A1, for example, if A1 is odd, 149 odds are left and we can use them, right?
Yeah.
So answer is at least 2. Again, do you agree by same proof we can say answer at least 3?
Yeah.
Okay, so try to see what's the greatest number that you can prove by this approach that answer is at least that. Okay?
Yeah.
Understood you should do what?
Yeah.
Okay, so try this part first on your own.
Is it 18?
Answer is at least 18.
Yeah.
Okay, can you prove why answer is at least 18?
Well, my thought was that if we do 300 divided by 18,
Exactly.
you get 16 remainder 12.
Just this one. 120 and 7, 6.
Yeah.
108 and 12, right?
Yeah.
Okay, then what?
There's 18 on top, so that means that from
For example, you say that if you select A1, A2 to A17, always we have a good choice for 18, right? You should prove this, right?
But my proof was that 18 wouldn't be possible.
Okay, 18 will be possible. Means that for 18...
No, it wouldn't. It wouldn't be possible.
It wouldn't be. It wouldn't be. We should find an example. But what about 17? If we divide 300 by 17, it is what?
17, yeah, I'm pretty sure that it works because if you do 300 over 17, you get 17 remainder 11.
8 times 7, 56. 5, 8 times 1, 8 plus 5, 13. 136. So it will be 17, right?
Yeah.
7 times 7, 49. We have 4. 7 times this plus 4, 119. It is 11. So from each remainder, we have at least 11, right?
Yeah.
So when we have A1 to A16, for A17, you need, for example, one remainder, right? From each of them, we have at least 17. Some of them 17, some of them 18. So from each remainder, there exists at least one number, mod 17. So always we have a good choice for 17, right?
Yeah.
Okay, so we can say answer is at least what?
17.
17, exactly. Good job. And the answer is near 17.
Yeah.
Now try to
definitely.
prove this part. Try, for example, here 20 or something like that. You should find an example that say, okay, for example, if you want to prove it is at most 17 or 18, you should say, okay, I select one, two, these, and for this example, these things are good, and we don't have any good choice for this one, right?
Yeah.
Okay, so try to see what number can you reach for this side, okay?
Okay.
Is it like something like I feel like it's 18 because like
Have you found any example?
Yeah, because like if you pick like every value which is like can be written as 18a, wait, no, actually, wait, give me a bit more time.
Okay, sure.
yeah, okay, I think I found a bad, like not a good way to get it, I think.
Okay, so have you found any example or not?
Well, like if you pick like 16, 18a plus 13, like numbers which can be written as 18a plus 13.
13. First one is what? A from what? A is from what? 0 or 1?
13, 0.
0. First number is 18 times 0 plus 13, right?
Yeah.
Next number 18 times 1 plus 13. Last one is what?
18 times 15 plus 13.
Okay, now
So
let's
this
go.
is 16.
Can you say it again?
Yeah, so basically there are 16 numbers which can be written as 18a plus 13.
18 times 15 is what? 270, right? So it's
Yeah.
283, right?
Yeah.
If you add 18 to this number, it will be 301, right?
Yeah.
Okay, so at first we should check y. If we check, for example, the remainders, for example, from 1 to y, it is multiple of I, right? So 18 times 0 plus 13, 18 times, for example, suppose first k elements, k minus 1 times 13 over k. We should prove it is integer, right? That k is at least 1 first element to 15, to 16, right?
Yeah.
So it will be what? 18 times k minus 1 over 2, which is 9 times k minus 1 plus 13k over k, right?
Yeah.
Which is 9 times k minus 1 plus 13. Okay, good job. If you write like this order, it will be good. And here, how many numbers are there?
16 numbers.
16 numbers. Now, what about next one? You want to have problem here or here? In 18, one, right? Because for
Yeah.
this one, we know always we have a good choice. If you want to have a problem here, the remainder should be 13, right?
If you want to help. Yeah.
So do you agree you need one more 13 here, mod 18, it should be 13, but here also we need 13, right?
So,
So for example, let me tell you this. For this one, you should select a number that this one be multiple of 17, right?
yeah.
So here we should place what this one mod 17 should be what? Suppose this one, for example, is A, or we have A, B. B mod 17 is what? Has to be what?
Um, B at mod 17 has to be 0. No. It has to be. Wait, I know that.
You should calculate this summation mod 17 is what, right?
Yeah.
So it's not hard. You can easily calculate the remainder of this summation mod 17. Want me to tell you or want to find it on your own?
I'll do it.
Okay, sure.
Is that minus 8 mod 17?
Minus 8.
Yeah.
Okay, let me tell you how we can calculate this quickly. Do you agree we said first k elements are these? So here first 16 elements, here k is 16, so 9 times 16 minus 1, which is 15, plus 13 mod 17, right?
Yeah.
So it's 9 times negative 2 minus 4, which is negative 18, negative 4, negative 22. It's negative 5. Understood your mistake? If you say your solution, I can tell you your mistake.
I just calculated the entire thing.
Understood my solution?
Yeah.
Okay, so negative 5 or 12. But do you agree if you place any number, for example, 12? If you select 12 here, again, we have a good choice here, right? Because you are using only 13 mod 18, and because it is not 13 mod 18 here, you don't need. Let me tell you, if you consider mod 18 here, for example, C, we want to see C mod 18 is what? For example, if it is 12, for example. Mod 18, do you agree this part is 13 times 16, right? 13 times 16 plus b. Mod 18 is 13 is negative 5, 18 is negative 2 plus b. Mod 18 it will be. So it will be b plus 10, right? So for example, if b is 12, 10 plus 12, 22. 22 mod 18 is 4, so we need negative 4 or 14. We have 14, right? Because you used only 13 mod 18, right? Okay, let me tell you something. Your approach was good, but you considered 13 because we have 16 remainders from that, right?
Yeah.
But do you agree if we select a remainder that we have 17 from that, it will be so much good because we use all of them here, and for this one we don't have any choice.
Yeah.
Exactly, it is exactly your approach, but you selected wrong remainder. So you should select which remainder?
18 times 0 plus 12. Or like
Plus 12 or plus 1, any of them, right?
Yeah.
Okay, so let's write 1. Yes, let's write 1 to be easier to calculate.
Yeah.
18 times 1 plus 1, and good job. Look, let me tell you, this problem 6 means the hardest problem of BMO1. Okay? So it is not easy at all. I can say difficulty of this is related to some problems of BMO2. And for example, one important part is that you could find this. One important part was finding this approach, and so much good. So if you consider 18 times 15 plus 1, next one 18 times 16 plus 1, right? And now do you agree all these numbers satisfy, for example, up to kth value? The
Yeah.
remainder, the mean is integer, like this approach, right?
Yeah.
And here, how many numbers are there?
There are 17.
Exactly. And if you consider, for example, this number as e, these 17 elements mod 18 are what?
Mod 17.
Let's write e mod 18 should be what? Because here we have 18 elements, right?
Yeah.
The mean should be integer, means some of them should be integer. So some of them should be multiple of 18, right?
Yeah.
Okay, so try this part.
E needs to be 1 mod 18.
Exactly, because if you consider this summation, it should be multiple of 18, right?
Yeah.
So all of them are 1. We have 17 ones plus E mod 18 should be 0, right?
Yeah.
Okay, so this one is 17. So E has to be 1 mod 18, right?
Yeah.
But do you agree we've used all remainders 1?
Yeah.
So that's a contradiction. You don't have any choice. So from this proof, we can say answer is what? At least or at most what? At most what? You didn't have any choice for 18.
So at most 17.
Yes, and also we proved answer is at least 17 here, right? So 1, if you use 1 and this one, then answer is equal to 17, right?
Yeah.
So here, like we used a small example on the sides here. For example, we said, okay, 1, 2, and we found the proof, right? And also for this one, that was harder. You found the approach, but we should select good remainder, right? Okay, good job.